June 2022. You can also use the mic chat or screen annotation to answer this. This question is about NMR, proton NMR spectroscopy. How many peaks are there in a low resolution NMR of a 2-methyl propane 2-ol? So we have prop, mean free carbon, OH is there, 2-ol, and 2-methyl is there. How many peaks will be there? 3. Yes, how many peaks? 2-methyl, 2, because these are identical hydrogen environments. Yeah, these are identical hydrogen, and this is 1, so this will have 2 peaks. Next, which of the compound? The next question. Which of the compounds has 3 peaks in NMR? Relative peaks of 3:1 means the hydrogen are like 3:2:1 in a low resolution. If I draw propanol, so CH3, CH2, C double bonded with ONH. So you can clearly see propanol, it will have 3, 2, 1. What about propane? Propane, CH3, CH2, CH3. But these two are identical. And this will be 6:2. So 3:1 will be there, but only 2 peaks. But we want 3 peaks. Already A is the answer. I'm just discussing them. So if it is propane 1-ol, propane 1-ol. So this is propane. So this will have 1, 2, 3, 4 peaks will be there. And propane 2-ol will have also 4 peaks. So 1, 2, 3, 4 peaks are there. Which compound does not have a singlet peak in high resolution NMR? Does not have. So if you want to draw the structure, butanoic acid. Look, whenever carboxylic acid or OH is there, definitely it will have a singlet, because that OH, whenever anything is having a OH, definitely it will have a singlet, because this hydrogen is like counted as alone. So butanoic acid will have a singlet. Yeah, the question is which, and same thing, aldehyde also. The question is which of the compound does not have a singlet peak? Singlet means like the splitting in a high resolution NMR. So if you draw the structure, CH3, CH2, 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 OH. This will give a singlet. For C, but confused. So if you draw the structure, aldehyde is there, yeah. So this will have a singlet. Why this will have a singlet? Because of the presence of OH. Butanoic acid will also have a singlet, CH3, CH2. Even without drawing the structure, you can identify C double bonded with ONOH. This will also give a singlet. So this will give a singlet. This will give a singlet. What about butanol? Butanol is CH3. But means 4 carbon. C double bonded with O, CH2 and CH. This neighbor is having 0, so it will also give a singlet. This neighbor CH3 neighbor is 0 hydrogen, so it will give a singlet. That's butanol. And butanol, what about butanol? CH3, CH2, CH2, C double bonded with ONH. So this neighbor is having 2 hydrogens, so this will give triplet. This neighbor is having 1 hydrogen, so this will give doublet. This neighbor is having 2 plus 3 hydrogen, so it will give like 6. And this will have 2 triplets. So butanol will not give a singlet. Okay. Rest all of them will give a singlet. Singlet is when the neighbor does not have any hydrogen. So 0 plus 1, it will be a singlet. 1. Is it clear, this one? The last one? The next question. The high resolution mass spectrum of organic compound X has a molecular ion peak. It has a molecular ion peak at 58.0417 and another peak at 29. So first thing, what are the peaks they can give? And the total mass should be 58. How, like, you have to add 1, 2, 3, 4, 3 carbon are there. So 12 multiplied by 3 plus oxygen is 15.9949 times 1 and hydrogen is 6. So that will give us the total mass of the compound. Usually like 15 plus, this will be 15, this will be 15 and how much is it? 58. 58.041. The full answer here. Yeah. Now, then is there any peak at 29? So there will be no peak at 29. Why? Because 1 is 15, then next is 28, then 15. If I break from left to right, it will give a peak at 15 or at 15 plus 28, 43 or then 58. Look, you just break the carbon bonds. If you want to know the fragments, you break the carbon bond. It is CH3, C double bonded with O and CH3. So this is one fragment, it will be 15. This is one fragment, that is 28, and this is one fragment, that is 15. So 15, either 15 will be there, 28, 15 plus 28, 43, or 43 plus 15. So the carbon and yeah. So we break from left to right and then we break from right to left. We'll know what fragments are there. Okay. And then you have to do for the other as well, like option B. If you see option B, in option B, it is CH3, CH2, C double bonded with O and H. So first, what is the total? Total will be 58. So this is 15, this is 14, and this is 29. Because 16 plus 12, 28 and plus 1. So if I break from left to right or I break from right to left, so it might give 15, it might give 29, and it might give 58. If I break from right to left, so 29 is there, 43 will be there, because 29 plus 14, 43, and then 58. So the question is, which is giving it another peak at 29? So this is giving a peak at 58, another peak at 29. So that's why B will be the right answer. Okay? So would we CH3, CH2, CH2, CH3. So this will be 15, 14, 14, 15. So this will be 15. But the problem, when you add the total mass will not be, because it does not have oxygen. So the total mass will not be 58.04. When you add them, when you add like the total mass of a hydrogen, exact mass of a hydrogen and carbon, the total will not be equal to this number. Because first thing, the molecular ion peak is this. So molecular mass should be 58.0417. And then the peak, even though this will have a peak at 29, but it won't have a peak. It won't have a peak because of the molecular ion peak will not match. Same thing for this one as well. Okay? Lack of oxygen is there, right? So B is the right answer. Because oxygen mass is an odd number. And here we have an odd number. So definitely, like if one oxygen is there, definitely the final answer will be an odd number. Because one of the number, this is even. This is even. Okay. This is odd number. and the molecular mass is an odd number. So it may give an idea that there must be an oxygen. Because how I will add two even number and I'll get an odd number. Yeah, because I'm not talking about the whole, I'm talking about the last. The last digit is an odd number, 7. Okay. So you cannot have a 7 by adding the even numbers. Okay. That's why. Okay. Next is in a high performance liquid chromatography, HPLC, use a column with a non-polar stationary phase and a solvent methanol and water. A mixture of octane, octanol and octane 1-ol. What is the order of retention time? Look, the stationary phase is a non-polar. So means it will absorb or attract the non-polar more. And so non-polar will take the longest time to move. So which is a non-polar substance here? So which is a non-polar substance? Octane is a non-polar substance. Because you have octane is there, octanol and octane 1-ol. Alcohol. So octane is a non-polar, so it will be attracted more towards the stationary phase. So as it will attract more towards the stationary phase, so it will take the longest time. Which will take the shortest time because alcohols have stronger attraction. Like if you see to water and methanol, so this alcohol will be attracted more towards methanol and water, it will move faster with a solvent. So octane 1-ol should take the shortest time. Then octanol is there in intermediate. But the depends on the intermediate force. Yeah, so intermolecular force. And it also depends on the stationary phase. Yeah. In a if we were having a low performance liquid chromatography, in that case, if it's a non-polar solvent, stationary phase, the opposite answer will be there. Yeah, for you mean if the non-polar was the stationary phase. Yeah. So you always check the type of the force, type of a molecule to understand. The longest time is the one which is attracted least to the stationary phase, and the shortest time is the one which attracted most towards the moving solvent. RF value of a substance, you have to use your ruler scale. Without calculation, I can tell that this RF value should be more than 0.5. Why? Because it is above half. Like if I have half of it, it's above half. Maximum is 1. And this, so it cannot be more than 1. It cannot be less than 0.5 because it is above half. And you can see it is about like, looks like 75% of the total. This is the test cover. So you can, or you can also use your ruler and measure. You can use your ruler or a scale and measure the distance moved by the solvent. Distance moved by the solvent and the solvent. So you can use your scale and measure this distance and divide. You will also get the same result. Okay. Next is which reaction cannot form a carboxylic acid? Primary alcohol, if I do oxidation of primary alcohol, will it form carboxylic acid? Primary alcohol oxidized to aldehyde and aldehyde oxidized to carboxylic acid. That's right. Yeah. Acidic hydrolysis of nitrile group. When a nitrile group we break down in the presence of acid, it will form a carboxylic acid. Yes, it does form carboxylic acid. Hydrolysis of the nitrile produce a carboxylic acid. How does the nitrile form by acid or nitrile? No, this is how nitrile is formed. We will first have a propanol or aldehyde or a ketone is there. Okay. We react with HCN. Okay. Yeah. This H will be attached to O and this will become CH3. OH is there. CH3 is there and this carbon is bonded. So this will become CN. Okay. And this is hydrolyzed. Hydrolyzed means like in the presence of, so what it will turn CH3, C, OH is there. This carbon C double bonded with O and OH will become and then CH3. So this is how a nitrile will turn into a carboxylic. This is substitution. First is the addition. First is the addition, nucleophilic addition reaction, and then is a hydrolysis. Addition, why it's addition? Because only one product is there. Oh. First is the nucleophilic addition, and this, yeah, first is addition and the second is hydrolysis. Then alkaline hydrolysis of the ester. It will not produce acid. Why? Look, when you do hydrolysis of the ester, what it produces alcohol and it will produce a carboxylic acid. But the problem, the carboxylic acid which is produced will react with an alkali and it will form a salt and water. So the carboxylic acid won't remain there. So that's why C will not produce a carboxylic acid, and acyl chloride reacting with water. If you have acyl chloride and if you react with water like H2O or HNOH, so this OH will take position of a Cl, so it will form a carboxylic acid. So these results, this will result in a formation of a carboxylic acid. Which alcohol could not be formed by reduction of aldehyde or a ketone? So how to know? Because if we have primary alcohol are formed, like if something is a primary alcohol, it will oxidize to aldehyde. If something is a secondary alcohol, it will be oxidized to ketone. But tertiary alcohol cannot be oxidized. So we just have to identify which is the tertiary alcohol. Because tertiary alcohol cannot be oxidized. So the question they ask in a reverse order. 2-methyl pentanol. Pent means 5 carbon. 2-methyl is there and 1 OH. So mean this is a primary because this have hydrogen. So this will be oxidized to form an aldehyde. What about this pentane 2-ol and 3-methyl? So this is a secondary because this is a carbon bonded with OH, so this is having 2 chains. So this is a secondary will be oxidized as well. But 3-methyl pentane 3-ol, third position a methyl group and third position OH. So 3 carbon chains are attached. This cannot be oxidized. If this cannot be oxidized, means it will not form either aldehyde or a ketone, or reduction of this will not produce an aldehyde or a ketone, because it can only produce primary and secondary, but not the tertiary. What is the pH of aqueous solution of a carbonic acid? The dissociation constant is given. Carbonic acid is a weak acid. Weak acid ionized partially.
Even if it is not a weak constitution of the presence of the K.
Yeah, from the K you can identify it's a weak acid. Yeah. So for a weak acid, like if you have a carbonic acid, it will dissociate. Like if you have a molecule of that, it will dissociate into hydrogen plus ion and negative ion. Initial concentration was 0.01. This will be 0 and 0 initially. But at equilibrium, this is X, so this will be 0.01 minus X. But we ignore, it will be 0.01 minus X, but because weak acids ionize partially, so we ignore their dissociation. So if I write the Ka, it will be a product divided by reactant. So product is the hydrogen ion, the negative ion, and then a hydrogen iodide. So dissociation constant is what? It is 4.5 into 10 power minus 7. This hydrogen and this is both are X, so X multiplied by X. And this will be 0.01 minus X, but X will be ignored because it is negligible, so it will be 0.01. This is divided, other side multiply. So this will become 4.5 into 10 power minus. No, this was already minus 7. Multiply by 0.01. Huh? Negative 9 is X square. If I need X, I will take a root both sides. Minus 5. And then take because this is the hydrogen ion concentration, so take the pH. So pH is equals to minus log of hydrogen ion, because the value of H is the hydrogen ion. So minus log of 6.7 into 10 to the power minus 5. How much? So 4.17. So it will be B will be the right answer. So this is how we always solve work for a weak acid. Yes.
So there was a question which is asked like for asking the explanation of why we is what's the explanation for assume that the H plus and the real line will be the same distribution.
Because we assume the one assumption that all the dissociation is only because of acid and there is no dissociation of the water. Water molecule does not dissociate.
So how can we link this explanation for the reason of why that's because that's possible. Oh, so you're saying like
this hydrogen is always from the acid, not from water, because this is not contributed from the water. It's always coming from acid.
How can justify the reason of why we assume that both of the ions form equal?
No, this is an assumption.
So
Practically won't be equal, but this we assume. And why we assume? Because we say acid dissociate, very negligible dissociation of the acid, plus the hydrogen ion are only from the acid, not from water.
So we eliminate the possibility of H plus from water, and since there is only a very little dissociation, so the probability of them being the same sign.
Yeah.
So it's for the sake of getting the answer for the equation.
Right.
There's two unknowns we can't find.
Yeah, two unknowns, so it will be impossible to find.
Okay.
Then the pH of aqueous solution, 0.227 mole of sodium hydroxide is there. The dissociation constant is given. So sodium hydroxide is a strong alkali. So it will dissociate into sodium ion and the hydroxide ion. So the concentration, which is 0.27, this will also be 0.27. This will also be 0.27. Then I can find POH minus log of 0.27. So what's the answer for POH? Yeah.
0.568.
No. Should be big number. 0.56.
Negative
0.27, yeah.
0.5.
Somewhere in which we get pH by. Yeah, how we can get the pH by pOH? Because first we got the pOH, and then the formula, the pH plus pOH will be equals to 14. That is one way. Or you can also solve this question by using a concept. See, the dissociation constant, the Kw, is a concentration of a hydrogen and the concentration of the hydroxide. So dissociation constant is 1 into 10 to the power minus 14. The hydrogen concentration is not known. OH ion is 0.27. 0.27 is multiplied, other side divided. So it will be 1 into 10 to the power minus 14 divided by 0.27. This will give the hydrogen ion concentration. And from hydrogen ion concentration, I can use the formula pH is equals to minus log of hydrogen ion. I'll get the pH of this solution, which is, what's the answer for this? B. Because we are definitely, it was 5, 6, so will be some 4, 4 something. So this is the way, like either you get the POH first and then subtract from 14. 14 minus the POH will get pH. Or you can use this method in which the Kw, the dissociation constant, is the hydrogen ion and the hydrogen oxide ion. So both ways will give us the same result. It won't make difference to the final result. Look, about this curve, you can see it's not starting with a very high pH. So it means it is a weak base. And it is going down around 1. So strong acid. So it's a titration of a weak base and strong acid, which is the titration of a weak base and strong acid. Yeah. So ethanoic is a weak acid. This is strong. This is strong acid, but this is a strong base. We don't want weak acid. We want a strong acid and a weak base. So D will be the right answer. Yes.
relative to, magnesium or, small,
No, how we identify it's a strong acid because the pH is very low. It's a like, yeah, yeah, strong acid. Yeah, related to ethanol. It's strong acid, HCl.
No, maybe one of them are weak.
No. It is strong. Which indicator is the most suitable? So you have to check the vertical part. In which region you have a vertical part? From 7 to it's look like 7 to 3. 8 will be a bit higher, I guess. Because if you divide into parts, this will be half of like it will be around 11. This will be around 3.5, like 12.5 it will be. So it does not look exactly 8. It is so 7 to 3, something in a range of a 7 to 3. So 7 to 3, which is the most suitable? Methyl red?
Yeah.
Because it is in the range.
Yeah.
What about methyl yellow? 2.9 to 4 as well.
So way low before
So, yeah.
the range of the soil
Yeah.
values with the range.
Yeah, it's like more suitable as compared to, because it's 2.9 is there. So it's more towards the curve part.
Yeah.
We want so both are in the range, but the best is short range. We like not about the short range. I mean the range in a vertical section from 7 to 3. This will be the good match as compared to 7 to 2.9.
Yeah.
So that's why we select a methyl red. Use the same link to join again.